At chemical bonding, and we're specifically going to look at covalent bonding. So our learning intention is to explore covalent bonding and double and triple bonds, including sigma and pi bonds. So the first thing to do would be to define covalent bonding, or what is a covalent bond. So a covalent bond consists of one or more shared pairs of electrons, and each of the bonded atoms contributes towards the shared pair. Another definition that we need to look at is a molecule. And a molecule is a group of atoms that are joined together. It's the smallest part of an element or compound that can exist independently. So let's have a look at some covalently bonded molecules. So the first molecule that we'll look at is hydrogen. Now we know that hydrogen has one electron present, so two hydrogen atoms join together to form a molecule of hydrogen. So one hydrogen atom shares its electron with another, and the bond is therefore covalent. So as we can see here, the hydrogen atoms have one electron each, as I've said, and they will covalently bond together by sharing their and each hydrogen atom achieves a stable electronic configuration like the noble gas of helium. This covalent bond can be shown more simply by using this simplified structure that I have just drawn now. Next we'll look at water, and we know that water consists of hydrogen and oxygen. So oxygen has 6 electrons in its outer shell, so it requires 2 in order to have a full octet. So oxygen will therefore share electrons with 2 hydrogen atoms. So if we look at the water molecule down in the bottom right hand corner of the slide, I'll draw the oxygen electrons in blue, and I'll draw the hydrogen electrons in yellow. And as we can clearly see, the oxygen electrons are being shared with the hydrogen in order for it to achieve a full outer shell, while we also have the hydrogen sharing its electrons with the oxygen atom to give it a full outer shell. Now if we look at this diagram, we can see that there is 2 pairs of electrons here on the top of the oxygen, and these are called lone pairs, and lone pair electrons are not involved in bonding. So next we'll look at methane, and as we can see, methane has carbon and hydrogen atoms present in its molecule. So carbon has 4 electrons in its outer energy level, so it requires 4 more electrons to have a full octet. So when it bonds with the hydrogen, the carbon shares its 4 electrons with the hydrogen atoms, so 4 covalent bonds are formed. And as we can see again, I've indicated this through the blue and yellow electrons. So we can see that the carbon's blue electrons are being shared with the hydrogen, and the yellow electrons from the hydrogen are being shared with the carbon to give the carbon its full octet and forming 4 covalent bonds. Now, as we can see, unlike the water, there is no lone pairs present in methane. So to conclude this section, we can clearly predict the number of covalent bonds that a molecule has. Carbon will have 4 covalent bonds, nitrogen will have 3, oxygen will have 2, and hydrogen will have 1. So since hydrogen can only form 1 covalent bond, we would say that it is monovalent. So we can say it has a valency of 1 because it cannot combine with more than 1 atom of any element. So that leads us to our definition of valency, and the valency of an element is defined as the number of atoms of hydrogen with which the atom of that element combines. So oxygen has a valency of 2, nitrogen 3, carbon 4, etc. So now let's look at some double and triple bonds. So to begin, a single bond is formed when 1 pair of electrons is shared between atoms. A double bond is formed when 2 pairs of electrons are shared between atoms. So a triple bond will be formed when there's 3 pairs, obviously. So if we take a look at an oxygen molecule, we can see that an oxygen molecule contains a double bond. And the reason for this double bond is in order for oxygen to achieve a full outer shell. And as we can see here, These electrons, the blue electrons in one oxygen, are shared with these oxygen here, and the yellow electrons in this oxygen are shared backwards with the other one. So it's a mutual sharing that occurs between oxygen to create our double bond. See that each nitrogen atom has 5 electrons, so it needs 3 more electrons in order to have a full outer shell. So each of these nitrogen atoms form a nitrogen molecule with a triple bond by sharing 3 of their electrons with each other to give a full octet. So let's move on to sigma and pi bonds. So single, double or triple bonds can be given specific names, and these names are either going to be a sigma bond or a pi bond. So let's begin with a sigma bond. So a sigma bond is formed by the head-on or direct overlap of 2 atomic orbitals. So here we can see we have 2 s orbitals overlapping. So this is head-on overlap of s and s. The next diagram we can see we have head-on overlap of an s and a p orbital, and the last diagram here shows head-on overlap of a p and a p orbital. So then we have a pi bond, and a pi bond is formed by the sideways overlap of p orbitals. So as we can see here, there is 2 places in which these bonds overlap. And a very simple way that I remember pi bonds is just 2 number 8s that overlap in this section here to form your pi bond. So if we take a look at our diagram here, we can see that a double bond consists of a pi bond and a sigma bond. So we can see that there is head-on overlap here between our py orbitals to form our sigma bond, and then there's sideways overlap of our pz orbitals to form our pi bond. So if we had a triple bond, then we would see the same bonding that we have here in our double bond, where we would have a pi bond and a sigma bond, but we would have a second pi bond coming from the pz orbitals, which aren't shown here on the screen. So a triple bond will have 2 pi bonds and 1 sigma bond. So if we were to look then at just the normal structures of bonds that we would see, we can see that oxygen here, it has a double bond in an oxygen molecule. So one of those bonds is a sigma bond, as indicated by the blue, and one of them is a pi bond, as indicated by the yellow. Where in nitrogen molecules, we have 1 sigma bond indicated by the blue and 2 pi bonds indicated by the yellow to form our triple bond. It's important to note that sigma bonds are stronger than pi bonds, and that is because of the orbitals overlapping more in sigma bonds than they do in pi bonds. So to finish up, let's look at the characteristics of ionic and covalent bonds in a summary table. So ionic compounds will have a network of ions in their crystal. They are usually hard and brittle. They have high melting and boiling points. They're usually solids at room temperature, and they conduct electricity when they are in their molten state or dissolved in water. Where covalent bonds, rather than a network of ions, they have individual molecules. They're usually soft. They have low melting and boiling points. They're usually liquids or gases or soft solids at room temperature, and they do not conduct electricity. That's it for this video. Have a read over the learning intention to make sure you understand everything we've gone through.